Hello my dear students, welcome to my channel Dey Sir's Chemistry Coaching. Today I am going to discuss expected questions and answers with detailed explanation on the chapter Amines. Now let's start the first question. This is identification test, okay? You will get one question from identification test. Now the first question is identify by single chemical reactions. This is the format of board question. Identify the following compounds by single chemical test. The question is methylamine and dimethylamine. Whenever you get any identification test, at first in your answer sheet write the structure of the corresponding compound. This is methylamine, this is dimethylamine. Whenever you replace one hydrogen by one methyl group, that's called dimethylamine. It's a methylamine. Just carbylamine reaction. Listen, carbylamine reaction or isocyanide test is the identification test of aliphatic or aromatic primary amines, that is amines containing NH2 group. When any aliphatic or aromatic primary amine is heated with a mixture of chloroform and alcoholic solution of potassium hydroxide, then isocyanide is obtained, NC, which has very unpleasant smell, and thus we can easily identify the given compound is a primary amine, while secondary or tertiary amine do not give isocyanide test or carbylamine test. So whenever you write the answer, write the reactions also. So methylamine being primary amine easily gives carbylamine reaction. When methylamine is treated with a mixture of chloroform and alcoholic solution of potassium hydroxide, then listen the technique, just change the amino group into isocyanide group, NC. It is methyl isocyanide. It has very unpleasant smell, and from the smell you can identify the primary amine. The byproducts are potassium combined with chlorine to form potassium chloride and water. This is very important. You should remember the balanced form. Just put here 3, 3 and 3. So remember it. You can identify any primary amine, whether it is aliphatic or aromatic, by carbylamine reaction. Dimethylamine being 2-degree amine does not give this test, so you can identify easily. Another reaction by which also you can identify primary or secondary amine, but remember it, in your board exam this type of question carries only 1 mark, so write only one reaction is sufficient. Now just listen the another reaction by which also we can identify this. Hinsberg reagent. Do you know what is Hinsberg reagent? This is very important for your time. Hinsberg reagent is benzene sulfonyl chloride C6H5SO2Cl. Benzene sulfonyl chloride. Hinsberg reagent is benzene sulfonyl chloride. So when say, listen, there are two beakers. One contains primary amine, another contains secondary amine, any primary or secondary. Just add Hinsberg reagent. It is available in laboratory in two. In both of the cases, you get precipitation. Cloudiness or precipitation takes place in both of the cases. Now, add dilute sodium hydroxide in both of them. If the precipitate is dissolved, that is primary amine. If the precipitate is not dissolved, that is secondary amine. So, when 1 degree amine is treated with Hinsberg reagent, short form, okay, Hinsberg reagent, PPT will appear, which is soluble in dilute sodium hydroxide. So you can identify the methylamine. That is methylamine you can identify. When 2 degree amine, that is this, is treated with Hinsberg reagent, PPT will appear, which is insoluble in dilute sodium hydroxide. So you can easily identify them, okay. Now the next question. I think you understand it, so follow the next question, okay. So the question, listen, identification test between aniline and any other compound, between aniline in one side and any other compound, such as aniline with cyclohexylamine, aniline with benzylamine, aniline with N-methylaniline. So write the answer. Only bromine water test. Aniline gives bromine water test, but other compounds they do not give. So you can write the answer in terms of bromine water test. So listen, what is bromine water test? Just take aniline. It's a colorless liquid. This is bromine water, reddish brown color. Bromine diluted in water, reddish brown color. So just add bromine water in aniline. After some times you see that the reddish brown color of bromine water is decolorized. That is, it becomes colorless. So you can identify that compound must be aniline, because no other compound respond to bromine water test. But the reaction is very important here. What is the reaction? Listen. So how to write it? When aniline reacts with reddish brown color of bromine water solution, the color is decolorized and we get a white precipitate of 2,4,6 tribromoaniline, 2,4,6 tribromoaniline. It is 2, it is 4, it is 6, 2, 4, 6 tribromoaniline. You get 2,4,6 tribromo. It's a white precipitate, very important. And side product, listen, whenever any atom or group is introduced on benzene, that is an example of electrophilic substitution reaction, and thus one hydrogen from benzene contains hydrogen at each carbon atom, so 3 bromines are introduced, so 3 hydrogens are replaced by 3 bromines, so you get byproduct HBr. So if you want to balance, just put 3. So remember it. You can write the answer in terms of bromine water solution when you get any question comparing identification test between aniline and any compound. Here, cyclohexylamine. How to write cyclohexylamine structure? Just remove the ring inside benzene, you get cyclohexylamine. Just remove the ring inside benzene, you get cyclohexylamine. Does not, because this is alkyl group, cyclohexyl group, alkyl group, and alkyl group does not undergo electrophilic substitution reaction, because for electrophilic substitution reaction that compound should have multiple bonds. Similar type of question you may find in aniline and benzylamine. Aniline, you know that structure of aniline is like this, NH2. So you can write, when treated with reddish brown color of bromine water solution, aniline decolorizes the bromine water to get a white precipitate of 2,4,6 tribromoaniline, while benzylamine does not. How to draw benzylamine? Listen, this is benzene. If you draw CH2 on the head, this is called benzyl group. Benzene having CH2 on the head called benzyl group, and just put amine, NH2. So remember it, this is aliphatic amine, because the NH2 group is not directly attached to benzene, so this is aliphatic, and aliphatic does not, though it has benzene, no. Here also you can write the answer in same way in terms of bromine water solution, aniline gives bromine water test, while N-methylaniline, how to draw N-methylaniline? Listen, 2 hydrogen atoms are there in aniline. Replace 1 hydrogen by methyl group, so it is N-methylaniline. Sometimes I have seen they used to give question in terms of not the language, in terms of the structure, or they may retain in this way also. So remember it, don't get confused. It is also N-methylaniline, Me. CH3 means methyl, Me the short form of methyl group. You can write it this way, same thing. So this is the important question, okay? These are the identification test. You must get identification test. Actually, I think considering aldehydes, ketones, carboxylic acid and amines, 2 chapters, you get 3 marks from identification test. 2 from aldehydes, ketones, and 1 from this, okay? And the identification test reactions are very important. So another topic you get from here, that is explain why or account for the following. So let's discuss the very important explain why questions which may come in your forthcoming board exam. So explain why. You get questions from here also, fixed question, okay? This is the format. The first question is, pKb of aniline is more than methylamine. Listen, pKb is the measure of basicity of amine. Remember it, pKb is a measure of basicity of amine. Greater the value of pKb, lesser will be the basicity. Now, You know that aniline, in aniline there is benzene ring. Benzene ring attracts electron from nitrogen atom, so the density of electron on nitrogen decreases. So basicity decreases. That's why aniline is less basic than methylamine. So pKb is high. Now what is the answer? Greater the value of pKb, it is a measure of basicity, okay? Lesser will be the basicity. Now you know that in aniline, due to the presence of benzene ring, as benzene has electron withdrawing nature, so it reduces the electron density of nitrogen, resulting decrease in basicity due to the presence of electron withdrawing benzene ring. The electron density on nitrogen decreases. So aniline is less basic than methyl amine, and better draw the structure also, okay? Better draw the structure. Now draw aniline, so benzene has, this is aniline electron withdrawing group, and draw methyl amine. You know that any alkyl group, that is methyl group, ethyl group has electron donating group which increases the electron density. So aniline is less basic, and remember it, greater the value of pKb, greater the value of pKb, okay, greater the value of pKb, lesser will be the basicity. That's the technique. I think you understand it. So the next question I have given already, that is, aniline does not undergo Friedel-Crafts reaction, okay? Now let's understand the question. That's a very important for your time. Three questions you will get from explain why. Now the second question I have given, aniline does not undergo Friedel-Crafts reaction. So why? So you should know what is Friedel-Crafts reaction. Actually, Friedel-Crafts reaction is the introduction of alkyl or acyl group on benzene. During Friedel-Crafts reaction, one catalyst is there, that is called anhydrous aluminium trichloride, AlCl3, and it's a Lewis acid. Actually, aluminium trichloride in Friedel-Crafts reaction acts as halogen carrier, that is, it attracts the chlorine atom from alkyl halide or acyl halide. But if aniline is used, due to the presence of lone pair of electron on nitrogen in aniline, instead of attacking the alkyl or acyl chloride, anhydrous aluminium trichloride, being Lewis acid in nature, gets attached to the lone pair of nitrogen of aniline to form anilinium ion, which has meta-directing or withdraw electrons from benzene. So the reactivity of benzene decreases. That's why aniline does not undergo Friedel-Crafts reaction. So let's understand the answer. This is aniline. Nitrogen has lone pair of electron. During Friedel-Crafts reaction, say if you consider methyl chloride in anhydrous aluminium trichloride, as aluminium trichloride is a Lewis acid and as it is a basic nature, so aluminium trichloride, instead of attacking the methyl chloride, it gets attached to the lone pair of nitrogen. So you get NH2 positive, AlCl3 negative, anilinium ion, and due to this anilinium ion, it attracts electron from benzene. So the ring is deactivated. Do you know what is the meaning of deactivated? The reactivity of benzene ring decreases. That's why aniline does not undergo Friedel-Crafts reaction. This is the thing. So you understand what is the answer? As aluminium trichloride is Lewis acid nature, it gets attached on the lone pair of nitrogen to form anilinium ion. As anilinium ion attracts electron from benzene, so the ring is deactivated, that is the reactivity of benzene ring decreases. That's why aniline does not undergo Friedel-Crafts reaction. Okay. Now the next question. So listen, another question. Primary amines have higher boiling point than tertiary amines. Why? Listen, whenever any question you will see relating to the boiling point, first thing is that whether the compound forms intermolecular hydrogen bonding or not, see it. Remember, if any compound contains oxygen hydrogen bond, such as alcohols, such as carboxylic acids, such as water, if any compound contains nitrogen hydrogen bonds, such as ammonia, such as primary amine, such as secondary amines, or any compound contains fluorine hydrogen bond, such as hydrogen fluoride, then the molecules of the compound form a long chain by association. This type of association is called intermolecular hydrogen bonding. And if intermolecular hydrogen bonding takes place, to break the associated molecules, more temperature is required. Hence, we can conclude that that type of compounds have higher boiling point. See the structure. In primary amine, that is, you can say methylamine, ethylamine, anything, okay? There is nitrogen hydrogen bond. In tertiary amine, the nitrogen is not attached to hydrogen anywhere. That's why primary amine forms intermolecular hydrogen bonding. So primary amine form association by intermolecular hydrogen bonding. Thus, to break the associated molecules, more temperature is required, resulting higher boiling point. You can draw the hydrogen bonding in primary amine. Not necessary, but you can draw if you are confident. Listen, as nitrogen is more electronegative than hydrogen, so there is partially distribution of charge, that is minus and plus. Here also minus and plus. Here also minus and plus. You know that oppositely charged ions are attracted by each other. That's why there is attraction force. This type of bonding is called intermolecular hydrogen bonding. And remember it, due to this intermolecular hydrogen bonding, the primary amine, say methylamine, ethylamine, forms a long chain. So to break the chain, obviously more temperature is required, resulting higher boiling point. Clear? So if any type of question relating to boiling point is there, at first think over it, whether the compound forms hydrogen bonding or not. How to know? Alcohols, carboxylic acids, amines, all form hydrogen bonding. They have obviously higher boiling point than any other compound which do not form any hydrogen bonding. Now, if two compounds are there, no one forms hydrogen bonding. How to explain the boiling point? It is the molecular mass. Greater the molecular mass, higher will be the boiling point, okay? Greater the molecular mass, higher will be the boiling point. So let's see one question relating to molecular mass. So remember it, there are three questions. From explain why you will get. This is the format of CBSE actually, okay, or ISC. Now the fourth question, okay. Now the fourth question is, which one has higher boiling point, aniline or ethyl amine? Okay, aniline or ethyl amine. Answer at first right, draw the structure, okay. This is aniline, this is ethyl amine. Now see, both of the compound contains nitrogen hydrogen bond, so both form hydrogen bonding. So we cannot explain the boiling point on the basis of hydrogen bonding, because both form association by hydrogen bonding. Now the second point comes, that is molecular mass. Aniline has obviously higher molecular mass because it has benzene ring than this, so it has more boiling point. So it has more boiling point. How to write? Due to higher molecular mass, aniline has higher boiling point, as we know that greater the molecular mass, more will be the boiling point. Remember it, boiling point is directly proportional to molecular mass. So I think you understand it. Now the question, there are two compounds, say one is alcohol, another is amine, primary amine. You know that alcohol contains OH group, primary amine contains NH group, so both form associated molecules by hydrogen bonding. Say if I say that both have comparable molecular mass, nearly same, how do you explain it? Both forms hydrogen bonding, both have nearly same molecular mass. So how do you explain it? Let's see another question, okay? So listen the question. Though ethylamine and ethanol have comparable molecular mass, that is they have nearly same molecular mass, but ethanol has higher boiling point. Why? This is ethylamine, this is ethanol. Both have nearly same molecular mass. So we cannot explain the boiling point on the basis of molecular mass. Now the second, hydrogen bonding. Ethylamine contains nitrogen hydrogen bond. Alcohols also contains oxygen hydrogen bonds. So both undergo intermolecular hydrogen bonding. But oxygen has electronegativity 3.5 and nitrogen has electronegativity 3. So you know that due to the higher electronegativity of oxygen atom in alcohol, the OH bond is more polar than NH bond. That's why the extent of hydrogen bonding in alcohol is more, resulting more boiling point. Actually, both form hydrogen bonding, intermolecular hydrogen bonding, but the extent of hydrogen bonding in case of ethanol more stronger due to more electronegativity on oxygen. That's why ethanol has higher boiling point than ethylamine. So how to write the answer? Draw the structure and then write the answer this way. Due to more electronegativity, direct write the answer, it only carries 1 marks. Due to more electronegativity of oxygen atom, due to more electronegativity of oxygen atom, the OH bond in ethanol is more polar. Okay, the OH bond in ethanol is more polar. Hence, the extent of hydrogen bonding in ethanol is more, resulting more boiling point. I think you understand it. Now the next, explain why. Okay. Now see the question. So the question, just go through the question. Ethyl amine is soluble in water while aniline is insoluble in water. Always remember the basic thing. Listen, the solubility of a compound depends on the tendency to form intermolecular hydrogen bonding with water. If any compound can form hydrogen bonding with water, remember that compound is soluble in water. Now question arises here. Both ethyl amine and aniline has NH group, NH bond. Listen, both ethyl amine and aniline both have nitrogen hydrogen bond, and you know that if any compound contains nitrogen hydrogen bond or oxygen hydrogen bond, they can capable of formation of hydrogen bonding with water and easily soluble. But question is that both can form hydrogen bonding with water. So both should soluble in water, but the question is aniline is not soluble or insoluble. Aniline is insoluble in water. There are two reasons. First, due to the presence of bulky benzene ring, aniline cannot form hydrogen bonding with water easily. This is known as steric hindrance, you know it. Another thing, due to the electron withdrawing nature of benzene ring in aniline, you know that benzene has electron withdrawing group. Due to the electron withdrawing nature of benzene ring, the polarity of NH bond decreases in such a extent that it cannot form hydrogen bonding with water. Generally, if you see, you say that, sir, aniline contains NH group, so it's form easily hydrogen bonding with water. No, actually in aniline, due to the presence of benzene ring, it undergoes resonance, and that's why nitrogen becomes positively charged. Hence the polarity of NH bond decreases to such extent that it is incapable of formation of hydrogen bonding with water. That's why aniline is insoluble in water. So let's write the answer. Draw it at first. Now in aniline, due to electron withdrawing benzene ring, due to electron withdrawing benzene ring, the polarity of NH bond decreases such an extent that it cannot form hydrogen bonding with water. So aniline is insoluble in water. This is the reason. Or you can write in another way also, due to the presence of bulky benzene ring, hydrogen bonding cannot take place due to steric hindrance, but it is better to write here, okay. Now the next question, do understand. So listen the question. Methylamine, when dissolved in water, it easily reacts with ferric chloride to form a precipitate. Why? Listen, methylamine has lone pair of electron on nitrogen atom, and as methylamine is more basic than water, so methylamine attracts proton from water to form methyl aniline ion and OH negative ion. This is the main thing. In the solution, ferric chloride also dissociates to form ferric ion and chloride ion. This ferric ion combines with OH negative ion to form a brown precipitate of ferric hydroxide or hydrated ferric oxide. Hydrated means having water. This is the main reason. So if this question will come, it is better to write the corresponding formula like this. And in language, how to write it? Once again listen. As methylamine is more basic than water, so it attracts a proton from water to give OH negative ion, hydroxide ion. This OH negative ion easily combines with ferric ion to form a brown precipitate of ferric hydroxide or hydrated ferric oxide. So let's see how to write the answer, okay. But again, I think it is better to write the reaction, and if you forget, only write the language. As methylamine is more basic than water, so it accepts a proton from water to give OH negative ion, which combines with ferric ion Fe+3 ion to give a brown colored precipitate of ferric hydroxide. So the next question, okay, do understand. So listen the question. Why silver chloride dissolves in methylamine solution? Remember it, whenever any compound dissolves in another compound, there is a possibility of formation of soluble complex, and silver chloride easily forms a soluble complex with methylamine, and due to the formation of this soluble complex, silver chloride easily dissolves, okay. Now the answer is silver chloride forms soluble complex with methylamine. So silver chloride dissolves in methylamine. How to write the reaction? Write silver chloride plus methylamine. So it forms a soluble complex silver CH3NH2 2 molecules, and in outside the bracket there is Cl, so put 2. This is soluble complex. Due to the presence of this soluble complex, silver chloride easily dissolves in methylamine. Okay, due to the presence of this soluble complex, silver chloride easily dissolves in methylamine. So I think you understand. Please do watch my next videos on amines that are all expected for your board exam. Thank you for watching.